Joining us now is Professor Alan Taub, University of Michigan.
Yeah.
Good to see you today.
Same here.
Let's talk a bit about your Symposium X talk. It's titled Challenges to Reduce Weight in Transportation Applications. So we'll start with, what are some of the challenges that you'll be addressing in your talk?
Yeah, well, what we're going to be talking about is we're one of the new Manufacturing Innovation Institutes, sponsored in a public-private partnership between the federal government and industry. Our particular institute is focused on reducing the weight of the machines that move people and goods. One of our big challenges is we're driving synergies across the industry sectors for land, sea, and air transportation. So it's everything from commercial aircraft to Navy ships to cars and heavy truck.
Of course, meeting those challenges, it has to make sense economically. So how do you balance that, the benefits with the economic issues?
Yeah. You've probably gotten to the critical issue in lightweighting. There have been prototypes for various OEMs for 20, 30 years that have shown you can lightweight, whether it's a land vehicle, an aircraft, or a ship. The key is it involves more expensive materials and more expensive manufacturing processes. What our goal is to reach that value equation for the consumer. So for example, for a light vehicle, such as a mid-sized car, you've got to get the cost of weight reduction down to about $2 per pound saved. Then fuel economy gets better and the consumer recovers that incremental cost.
Now, in addition to the advanced materials you're talking about, you also talk about coupling those advances with computational engineering. How entwined are the fields of material research and computer engineering?
Yeah, the breakthrough that's really occurring in, I'd say, the entire materials research industry, but in particular in the structural materials, is called Integrated Computational Materials Engineering. In Washington, called the Materials Genome Initiative, so it could sell it.
Right.
The technologists prefer ICME. What we're able to do for the first time is through multi-scale modeling, start with calculations at the atomic level, scale that up to how the structure and microstructure of the material develops during manufacturing, predict that structure, and predict the properties of the material locally in the component. That really enables the designers to now work with the manufacturing engineers and develop the truly optimized component around these new materials. It is just beginning. Ford had a breakthrough using it on their last engine block design. Boeing and some of the aerospace companies are now using it. It really is the new revolution in materials research.
And you kind of leading to my next question. In your talk, you're dealing with challenges looking to the future. But let's look back. What are some of the successes we've seen in the past few years?
The introduction of the advanced high-strength steels in land-based vehicles. They've reduced the weight of those vehicles by almost 20%. And the key is using the same equipment that was already in the plants. It was really the metallurgical advances that enabled it. You saw in the pickup trucks, Ford recently introduced the F-150, and of course Boeing introducing carbon fiber composites in commercial airline.
Professor Alan Taub, thank you for your time.
My pleasure.
It's good to meet you.